There's 7 billion people in the world. Every person generates approximately half a ton of waste per year. What that means is there's 3.5 billion tons a year of wasted resources. Approximately 40% material in most developed countries is being recycled.
Even if recycling is sent to recycling centres, there's so much potential for it to be missed. Anything wet, anything food contaminated, anything mixed materials such as sandwich packs, envelopes, anything plastic lined, coffee cups, pizza boxes, Tetra Pak, they've got perfectly good materials, but they just can't be recycled in the current system.
This is valuable raw material and it's just being thrown away. There needs to be a paradigm shift in the way that we treat waste. Fiberight spent the last 12 years developing a robust system based on known technology that allows us to economically recover materials that nobody else can.
The current recycling system is really afraid of water. Anything wet is sticky, it sticks to other materials and they can't separate it. We've really turned this all on its head, and our HYDRACYCLE process uses water to be able to separate out the different fibres and the organics from the more inert materials. We can get over 70% recovery and recycling, even up to 95%. So the residual waste comes into our process, and first we debag it, and then we pulp it down to break down the organics, so we're able to separate those organics from the inert materials. We get that dirty organic stream, so it's got the food waste, the paper waste, and small bits of plastic, and then that's washed so that we can solubilize the food waste and recover the fibre.
That food that gets washed out then goes into anaerobic digestion that allows us to generate power, or we can compress and clean the gas and it can go back into the gas grid. The Fiberight process creates a number of different output streams. The first output stream that it creates is a clean fibre pulp.
That can go into pulp molded products, containerboard. We've also developed the technology to take that pulp through to sugar for industrial biotechnology applications. So the inerts, the flexible plastics, the rigid plastics and metals, they're all separated. Rigids is your pots, tubs, trays, flexible plastics, your plastic bags, film packaging. What we're doing with those is trying to separate out the different polymers so we get a pure monomaterial flake, and then we can pellet that, and that pellet can go back into a manufacturing process. We didn't expect to find any metals, but we're seeing 5–10% metals in the material we're getting, and that just tells you how inefficient the current system is.
A key to Fiberight's approach is the fact that we regard ourselves as a manufacturer, not a waste processor. We just happen to use waste as a raw material.
We wanted to develop a process that was robust and flexible and feedstock agnostic.
It can either take the residual waste from the sorting plants, it can take the black bag waste that's collected on curbside, or we can take commercial waste from the back of a restaurant or a fast food store.
At Fiberight, we're trying to achieve the end of waste. And our motto, don't bury it, don't burn it, use it, really alludes to the fact there are so many resources still in residual waste that are going to landfill or incineration. We want to recover these resources and return them back to the circular economy.